Hello, today we will see how can we easily design a PCB as well as how can we simulate our circuits virtually uh, by using EasyEDA software or the web version of the EasyEDA. EasyEDA is a very powerful and is a very simplest platform to design and simulate the PCB. Here you can see that the simulation mode is there, and also the standard mode to design the PCB is available here. Now we are in simulation mode, and if we want to go to the standard mode, that is to design the circuit and to make the PCB design, you have to click there, and now we can see that now we are in standard mode. Now in the EasyEDA software, at the right hand side upper corner, you can see that there are two options like login and register. When you will start, at first you have to register over here. You can register or you can create your account by either by using your direct from your Google, okay, or either by using directly your Gmail, or you can put your username, email and password. After that, job function you have to select, okay. Then you can create your account from here. This is completely free. After you fill up this portion, then an email message will go to your email account. You have to click on that email to activate your account. After that, you have to log in. As I have the account, so I'm not going to make another account. I will just show you after logging over here with my credentials, okay. Now you can see that I have already logged in my account. So there are some designs I have already prepared. Now I will create a new project over here, right? So I will design the PCB of Renalum circuit, okay. You can put your description over here. Now click on save, okay. Here you can see that Renalum project folder is already created. So here you have to draw the schematic of your circuit, okay. So this is our circuit. This circuit I had found from Google. I will put the link from where I got this circuit. I will put my link in the description section. You can go there and check the details about the circuit. So to draw the schematic of this circuit, at first I will take 555 timer IC, okay. So in this software we will get the components from this libraries option, okay. From this library option we'll get the components, the footprint of the components, okay. So here I will type 555, then enter. So that 555 IC I have to found from the list. Otherwise you can use this left hand side. You have to scroll over here and you have to go to ICs. Okay, analog IC. There are several options. Here in the logic ICs, as this is the logic IC, so I came to this portion. Okay, here you can see TLC 555 CDR. Okay, this is manufactured by Texas Instrument TI. Okay, this is SMT type, or what is the package that's mentioned. Now I have to found the DIP package. This is the SYC SMT package is there, so I have to found this any 555 SYC. This one is also SMT package, any 555N. This is DIP package. You can also see that the actual picture of that these things. Okay, actual ICs. Okay, so the name of the manufacturer is also written over here. The description is also there, the DIP dual inline package of 8-pin IC. Okay, and what is the length, width, and pitch? That means the distance between the two terminals, uh, between the two pins, that is terminals of the ICs. Okay, that is 2.54 millimeter. And etc. The descriptions are also available. You can also get the detailed description after clicking. If you click on that picture, you will directly go to the lcsc.com, and there you will find that the description of the data sheet and everything you will get from here. Okay, so now I will click on here and then click place. So I'll be able to place over here. Okay, next I need to find out BC547 transistor. Okay, so again I have to go to libraries, BC547, enter. BC547, this is in TO92 package on Semicon. This is the manufacturer. Click on it and again place. Okay, fine. Next I need BC557, so again I will write over here and press enter. So BC557 CJ, it is available. Okay, CJ description. Okay, place. Then I need 39 ohms resistance. Okay, again I will go to libraries, then you can also write over here that 39 E. Okay, 39 ounce, but it is quite difficult to find out the exact one, the wattage and the types. So it is quite easy to find it if you try to find out from under the resistor section. Metal oxide flame resistance. The description is written over here, that is metal oxide half watt 2k 2 kilo ohms, 5% tolerance value, 1 watt. Now I will take it. Okay, here 1 kilo ohms is there, so the same thing, 1 kilo ohms. Now I'm just randomly placing over here. Then sorry, the library is 10 nanofarad, 10 nanofarad. Okay, again another 10 nanofarad is there, so I will put two quantities, 33 kilo ohms, 47 kilo ohms, right? So 33 kilo ohms. Thirty-three kilo ohms. If you are unable to find out the exact value, you can take any values and you can change, like I'm just showing you. Where I click on it, you can go out from that command, you can change the value also from here. 33k. Okay, but I will not use like that way. You can use it, I also can use it, but I will just take another chance to find the same from CFR. Okay, from the CFR 33k I will try to find out half watt 33 kilo ohms. This is a 2 watt. Okay, metal oxide resistors. You can find out from here. will just go with this one plus then 33k. I did it because the length are same. And 47k. I will just make a copy of the same. Control C and Control V. Okay, 33k. This should be 47k. Okay, 47k. Length are same, so I just made it like this way. Then BC547, another one is required. Okay, so BC547 I will again Control C, then Control V, then 100k and 10k are there. 100k and 10k. So I will just copy and paste the same and make here 10k, and this should be 100k. Okay, fine. So all the components are placed. This is the rain direction plate. Here basically the some copper plating is there. So if the water droplets are there on that plate, so the positive and negative line will be short circuited and the current will flow from here to the base of this BC547, this NPN type transistor. Okay, so I will not draw it over here. Later I will show how can we just make it in our PCB. Okay, now for now we will just purchase it from the online, and you can use it along with your circuit. So here another components are missing right present, that is 8 ohm speaker that I will put in my circuit, and there should be two terminals. Okay, here the supply terminal should be there in our circuit, that I will put screw terminals of 2 pin, and here also I will put 2 pin screw terminals. Okay, so let's find two buzzer. There are different types of buzzers are there. Okay, 12 mm buzzers are there. You can choose whatever you will actually purchase from the market or from online, and how we want to design, you have to choose according to that. Okay, now for now I am using this one, the buzzer, like, okay, and the screw terminals should be placed on here to supply and to connect the raindrop direction plate. Okay, so from here you can also directly fetch the uh, modules also. Okay, so now I will go to terminals. Here I had put the USB connector instead of the screw terminals for power supply, so that you can easily supply on this PCB, and the screw terminals I will put to connect the plate, ventilator plate. Now I want to change the buzzer. Actually, I want to put this buzzer, so this one I will delete, and then I have to find out that screw terminals, right? So to library, KF300, this is 3-pin terminal lock. Okay, so right, this is KF300, 5 mm pitch and 2-pin terminal lock. Okay, this is known as screw terminals. Place over here. Okay, so now we have to connect. So from the VCC we'll come to this one. From the reset it will directly be connected with 4 and 8 should be directly connected. Okay, 4 and 8 and 4 are short circuited. Okay, so from this tree, this is the output terminal of 555 IC. So this pin is connected with one terminal of 1 kilo ohms resistance and another terminal of 33 kilo ohms resistance. So 33 kilo ohms resistance. Okay, this should be here, and 1 kilo ohms resistance, this also should be here. Place this. Okay, okay, from here to here. Okay, this is already done. Okay, another terminal of 33 kilo ohms resistance should be connected with 2 and 6. 33 kilo ohms resistance is this one, so I will make it from here to here, and these will be connected with this one, right? Okay, now from the another terminal of 1 kilo ohms resistance should be in the base of this BC547. So BC547, I place it over here, and from here to here I will connect. This is the base. Okay, then collector should be connected with 8 ohm speaker. Okay, collector, that is this one, it should be connected with this one. Okay, then another terminal of the buzzer should go to the 39 ohms resistance. 39 ohms resistance over here, so I will place it here to here. Okay, this is the wire. By using it I will be able to connect the things. Okay, so the another terminal should be connected with the 6 volt supply, so I have to make the circuit close here. Okay, and now 8 and 4 are not directly connected with the supply, so I will remove this one. Okay, I will remove this one. The BC557 will come to this position. This one, okay, this one would be okay, and this one would be over here. Okay, this terminal should go to the 8, this terminal go to 8, and 4 should come to the same line. Okay, now this portion is okay. Another thing is a 10 nanofarad capacitor should be there. Okay, okay, this is also connected, and then this portion is I have to connect, so 100k and 10k should connect to the power supply. So 100k and 10k. Hundred k and 10k there. Then 10k. This line is completed. So from 100k it should go to the basic 557. From 100k should be connected with the basic 557. Then the same should go to the 47k. So from here we'll connect here. Okay, and this one will go to the base of the base of here. Okay, fine. Then collector. 47 kilo ohms. So it should go to the collector only. Click and press delete. So to come to the collector from the 2-pin terminal block. Okay, and then this one should go here. Okay, so now I have to connect the ground. Ground from here to here. This one, and from here to here. Okay, so as per the circuit diagram, I completed my schematic. Okay, so now in the title box you can change the name. Sheet 1 of 1. Okay, I didn't connect all the ground connections through the wire because I will make the PCB ground. I will make the PCB not. I will not connect the ground, all the grounds through wire. I will make it ground netting. I will done. So I connect all the ground individually, which will be internally connected. Okay. So after that, you can save your schematic from here. It will automatically come to under your projects. Okay. Then you can see the BOM, bill of material, BOM. Okay. In details, you can export the BOM, bill of material, in your desktop. You can order parts or check the stock from the online also. You can order it from here or as per your choice. You have to log in at first, and then it will show the estimated cost and the delivery details, etc. Everything it will show over here. It is a very helpful software because you will be able to order the PCB directly to the company also. Okay. So now actually from here you can share your friends and friends also to join and contribute in a particular design and check and verify everything. Okay, you can share. Or now I will go to the, you can also do the simulations. We used to do the simulation because of to verify the circuits before going to deal with directly the hardware components. It actually saves our time if we did some mistake. Say some components are not required, or some other components are required, extra components are required to fulfill the output, fulfill the purpose of the circuit. Then it is the best way to simulate the circuit before going to deal with the hardware components, because then virtually we will be able to provide the input, and as per the design we will be able to see whether the outputs are coming properly or not. It saves our time, money, and everything. Okay, so now for now I will not go to the simulation mode for now. Later I will show how to simulate in this software. So uh, now I will go to the PCB. So from here you can have to click the convert to PCB. Yes, check nets. It will check the net connections, the nets in the circuit. Okay, so I will put over here as this pin number 7 and not in use, so I have to put the no connection, no connect flag. Okay, then if I click okay, and this one, the data pin of the USBs are also open, so I have to put it over here and save, convert to PCB. Now it will come. Okay, see, now in this section, from here you can set the units. I'll set the units in millimeter. Here you can change the size of the board. Okay, you can click on here. You can choose rectangular board, circular board, or round rectangular board. Okay, so what would be the width? If you have any boundary conditions, then you can put from here, like, or later also you can modify it. At the beginning I will just keep it like this way, 50 by 50. I think this should be somehow. I would make it 80 by 80. Okay, later I can also change it. Okay, that is not an issue. So now I have to put the components. So the components will put here the USB. Then it is simple as it is, because you have to just drag and drop. You can rotate it. Just click on the section, then from here you can rotate. Okay, these small dots are this small dot should lie in the inside the board, because this is the entry point of the wires. Okay, so 555 timer IC should stay just here. This one should be here with the rotation. Okay, this one can be here. Okay, this one can be here. Okay, these four things. Okay, so we'll just select it. You can scroll to zoom in or zoom out. Okay, so now we will make the track. You can do it manually or auto router you can use. Okay, so to use auto router, here the unit is already settled as millimeter. The track width you can set. It is I need 1 mm track with a clearance of 0.8 millimeter. Wire diameter are not required because I will make it a single layer PCB. Here the real-time display, the how the tracks are made, it will show. If you click on it, if you check it, or if you uncheck, it will not show. It will directly uh, give you the result. I will check it, so it will show the real-time display of the tracks when it will be made. The router server, as you are using auto router, it will the program will run in the background either from the cloud or from the local. And now for now I will show it from cloud, or if you want to make it from local, so we have to take, like, you have to download this Easyeda router option. Okay, from this, if you click on it, it will directly open a web page. From there you can get the instructions also from here, or and as well as you will be able to find the link. You have to download this one. I have already downloaded it. So this one, after download, you have to unzip that one, and then you have to run this Windows 64 option. Okay, now auto router, this local is available. Okay, local means that the program will run from that folder only. Okay, so in the router layer, it will by default check the two layers, that is top and bottom layer. But if you want to make a single layer PCB, you have to just uncheck this top layer. If you have any special net options, you can put it here. Skip nets, I will not put right now. Then track width, again I have to put 0.8. Okay, then run. So basically the components, here you can see the yellow color components are placed in the top layer. Okay, so and we are uh, designing the tracks in the bottom layer. Okay, that is a single layer PCB, so I choose it. It will take some time as per the internet speed. If you use cloud and if you are using local server, then it will depend upon the specification of the computer. So it is showing that it could not test some the tracks along as per my instruction. So you can make it with your own hands, or you can change the placing of the components also. But before that, I will make copper area, that is ground, at the bottom layer. So now I'm just delete I will delete the ground lines. So here you can see that the all the grounds are net connected over in the PCB, in the bottom layer of the PCB. So all the grounds are connected internally, and the just copper netting has been done over here. So here I will just make it as 0.8. Okay, then right click on copper it and rebuild all, and it will automatically rebuild the copper area. Okay, see, whenever you will just shift the track, then if the cross mark comes, then that means this track is overlaying on some other tracks or the other nets. So like here the ground nets are there and the track is here. So whatever the basic distance, that means the clearance I have set in that 0.8 mm. So now after as I shift this track, so the difference distance between these ground nets and the track are now less than the 0.8 mm, so it is showing cross mark. So it basically automatically counts the distance between the tracks. So now I have to put the holes from the mounting holes, so I will put it on here. See, the red uh, marking are highlighted, that means it is shifted somehow. Okay, it is not aligned with the bottom one, so now it is not highlighting, so it is aligned. Okay, then here it's aligned, and here also I will put it on the track, and after that I will shift it. Okay, so now I have to shift the track. It's not an issue. Okay, I will shift it. So okay, I will make it straight. Variable tall. Okay, and for this one, okay, I will just lower it down, and then now again rebuild the copper area. Copper area is rebuilt it, so now it doesn't have any problem. Copper area rebuilt. Fine here. Okay, I will just shift it, and here also I can shift, not an issue. So okay, the work is done in the bottom layer. Okay, so at the top silk layer, I will write a text like here. I would like to write the name of the PCB, rain alarm. Okay, you can change the font also. Okay, on light or something, by default it is okay. You can change the other fonts also. You can add from here. Okay, you can add something from your library, and you can change also the point 3. Okay, rain alarm. Okay, just I will keep it as it was. It can be 2. Okay, so okay, wait, 0.5. Okay, is it okay? Yes, it is okay, not an issue. Don't think about this track, because this is at the bottom layer, and I'm now working on the top silk layer. That is where the and the top side of the PCB. Okay, so here I need to write the power here. Okay, I input power supply PS 5 volt DC. Okay, so it should be like, I should fit it over here. So okay, fine, it's perfectly fitted here, no problem. Copper here rebuilt. Okay, see, this is the ground, so ground is already knitted with the button layer copper, and this is a positive, so it is connected. and as there are no connections, pins are not connected with any component, so this is kept open. Okay, so here this one I will rotate left, and then put it at top of the components. Now here again I need to write the, I will copy it and paste here, like following this one. Okay, I will just align this one, then this one, and again we will done. Okay, rain sensor, let enter. Okay, this is written. Now okay, so this is buzzer public alarm. Okay, alarm. Okay, so here you can see that our PCB is already prepared. Just some finishing touch I will provide. Every time you need to repeat the copper area. If you change the position of the track manually, here this R2 should be rotated. So okay, you can stay downside. I'm not going to mention the exact value of this capacitance, resistance, etc. I am just going to put it as just only as a notation. Okay, so okay, here Q1. Okay, it is unnecessarily routed more. Here also the same thing. Okay, wait. This one also unnecessarily routed more. So I will just make it minimum as possible. Okay, and this one. Okay, fine. So here it basically looks odd actually. So okay, and move it from there to here. Part 3. Rotate right. This R1. Rotate right. Come from here. Okay, fine. Okay, this one. Rotate left. This one also. Rotate right. Okay, etc. Okay. Okay, so our work is now complete. So okay, from the document I have saved it in my project file. In my project file you can see that the PCB file is already saved. Okay, so now from here you can see the photo view, how it looks like. Okay, and also you can see the 3D view of the same, like how the tracks are made and a complete gesture of the same in 3D view. You can see, you can export the BOM bill of material. You can generate the fabrication file, that is Java file you can generate. Okay, by checking the BRC it will generate the Java. You can download it from here. You can view the Java view if you have the Java viewer, then you can view directly, or else you have to go to the online, and from the website you can check the Java view also. Okay, so you can also order from here. Basically in this software you can't set the layers as one. You must have to set the layers as two, and if you want to make a single layer PCB, then you have to only route in one layer, either top layer or bottom layer, as per your choice and systems. Okay, so you can also order at JLC PCB from here directly from the software. The automatically this Java file will be uploaded there, and you will get the PCB price, estimated delivery time, and everything you can get. If you wish to order here, you may proceed, or you can also check as per. You can also make the PCB as per your convenience. Okay, so you can also export the. You can also save it as a module. You can export the PDF file. You can also export it in TXF format, or in Altium, EasyEda, which is source, etc. Like see here, from here if I click on export document, export to PDF, size 1:1 directly in 1:1 scale, then you can click on here like engine, local engine. Okay, fine. Assemble drawings, full graphics, object outline. I will choose a full graphics. Type merge layer, page layer, separated layer. Each layer will be separated in separate sheet. Okay, if you do the PCB in your home, then you need this one separated layer, because the bottom layer should be mirrored. So okay, you can get the things, and you have to click on export in PDF format. It will ask to where you want to save your file. So I'm not here. I will write rain alarm. Okay, so I'll save it in my desktop. So if I go to my desktop, I will find this one. Now it is okay. Okay, separate layer, black and white color, black on white background or white on black background or full color, whatever you want. Basically black on white is okay. So I can open it with this one. Okay, it has some problem. It is showing. Okay, again I am going to export it. PDF, white and black, black and white. Okay, export. Then okay, I will keep this name as it is. Okay, so now you can see all the holes are placed as per location. In bottom layer you will find the tracks. Okay, so from here we can see that the tracks are just overlaying, so we have to change it. We have to modify it. You can find it the top layer also, and top layer the component placing and etc. You will find it, get it from here. Okay, so here I will move, and okay, this one is okay, I think so. So we're going to cover area. Yeah, now it's fine. Save, and again I will export the same. Layer. Okay, the button layer. Now see the clearance is there, so it's okay for now. Okay, you can change the color also from here. Like button layer is now in blue color. If you want to make it as red, you can make it. And if you want to make it as blue, you can change it. Settings. See, the colors are already changed. Okay, you can change the color also from here. And the thing is there, the thing is that this copper layer you can't make it as one. Okay, you have to always choose two, and at the time of routing what I shown is at the time of routing we have to either you have to uncheck this top layer, or you have to uncheck the bottom layer if you want to make a single sided PCB. if you are interested to make the single-sided PCB. Okay, you can also find the dimension of the PCB, like from here to here. See, 63.119 millimeter. It is from this option dimension from here to here, 52.451 millimeter. Okay, you can also you can also import your logo or image. So you can select an image file. If you have any image, you can import it. You can change the color tolerance, simplify the label, and etc. You can uh, modify the image size also and insert the image to the PCB. So click here, then you'll get it on here, either on bottom side or top layer or wherever you want to place it. Okay, so here basically I show you that how to make the PCB design. But if you were interested to make it more efficient and to make it more compact, then you have to place the components one by one, and as per the position actually which components are closer to which components, according to that panda you have to, that means like say here this 10K register is quite closer to this VCC, and this register 33 register is quite closer to the pin number 3 of any 555N. So here I didn't put the components like that way. That is why it looks chaotic, and the board size has also increased. So if you place it more precisely and if you take care about this placement of the components, then it will save your money and the size of the board will be more compact, unless and until you are bound to make the particular size PCB. Okay, and thank you.